Hi students, okay, today we are learning the topic is the second theorem, Lagrange's mean value theorem. The first theorem is completed in the previous lecture, that is a Rolle's theorem. So here now in this lecture we are discussing what is the statement of Lagrange's theorem and verification of Lagrange's theorem and also geometrically interpretation of the given theorem. Okay, now first of all see the statement. So let f from closed interval a comma b tends to R be a function such that it is continuous in closed interval a comma b, it is differentiable in open interval a comma b. Then there exists at least one point C between a and b such that f dash of c is equal to f of b minus f of a by b minus a. So here only two conditions are satisfied, but Rolle's theorem lo three conditions satisfied. F of a is equal to f of b. So now here Lagrange's theorem only two conditions, continuous and differentiable. Then there exists one point between a and b such that this condition is satisfied. F dash of c is equal to f of b minus f of b. Okay na? So see the another statement of the Lagrange's theorem. So this is another statement. Yeah, let f from closed interval a comma a plus h tends to R. And in the above statement lo b place lo a plus h, and a plus h is the near point of a. So b is the function such that it is continuous in closed interval a comma a plus h and it is differentiable in open interval a comma a plus h. Then there exists a real number theta is belongs to 0 comma 1 such that f dash of a plus theta h is equal to f of a plus h minus f of a by h. So this is a theta. Theta is any real number, and also sometime we choosing theta is a negligible value. Okay na? So this is the another statement of Lagrange's mean value theorem. So now we are see that geometrical interpretation of the theorem. So geometrically interpretation of Lagrange's theorem, see that here. So if the function f of x satisfying all conditions of Lagrange's theorem, then all conditions means two conditions, continuous and differentiable. So that is equal to, then the graph of y is equal to f of x is continuous curve from the point a comma f of a to b comma f of b on the curve. So that is equal, see that this is a graph. So from a, this is the a point, and a comma f of a is the x coordinate, f of a is the y coordinate, and b point, b is the x coordinate, f of b is the y coordinate. From the point on the curve from a to b is continuous curve, there is no breaking end. Next second one is differentiable. Differentiable means there exists a unique tangent. There exists a unique tangent at every point on the curve y is equal to f of x between the points. And between a and b at every point a unique tangent exists. Now assumption, then there exists at least one point C on the curve y is equal to f of x between a and b where the tangent is parallel to the chord AB, joining two points of a and b of the curve. So joining means these are two end points joining, and so this is called chord, AB chord of the curve, and observing this is a tangent. This tangent both are parallel. This tangent line, this is a AB chord at the point C, both are parallel. That is equal to tangent curve is slope f dash of c. F dash of c is equal, and AB chord slope, that is using the formula y2 minus y1 by x2 minus x1 here. That is f of b minus f of a by b minus a. F dash of c is equal f of b minus f of a by b minus a. That is equal to where the tangent is parallel to the AB chord. So this is the geometrically view of Lagrange's mean value theorem. Okay, is it clear? Okay, see the next verification of Lagrange's theorem. So verify Lagrange's mean value theorem for f of x is equal to x into x minus 1 into x minus 2 in closed interval 1 comma 4. So given f of x is equal to, simplification is x cube minus 3x square plus 2x. So that is equal to here. So clearly given function is continuous and differentiable because this is a polynomial of degree 3. Okay, na? So and differentiation is 3x square minus 6x plus 2. So that is equal to, they exist for all between 1 and 4. At every point between 1 and 4 is exist. So clearly continuous and differentiable. So Lagrange's theorem is applicable. So see that Lagrange's mean value theorem is applicable for f of x in closed interval 1 comma 4. So now verification to finding at least one point C between 1 and 4 such that f dash of C is equal to formula f of b minus f of a by b minus a kada. If a is equal to 1, b is equal to 4, that is f of 4 minus f of 1 by 4 minus 1. So f dash of C means substituting in the f dash of x, that is equal to 3c square minus 6c plus 2. Okay, na? F of 4 means in the substituting in the given function f of 4, that is equal to 24 minus f of 1 is equal to 0 by 4 minus 1 3. Simplification is 3c square minus 6c minus 6. So 24 by 3 means 8 inside, 2 minus 8 the minus 6. So this is the quadratic equation. To take the roots, 3 common here, c square minus 2c minus 2 is equal to 0. C is equal to roots here 1 plus or minus root 3, and this is a rotational roots 1 plus or minus root 3, which value is belongs to in the given interval 1 comma 4. So that is equal to here C 1 plus root 3. Only 1 plus root 3 means is belongs to 1 comma 4. But 1 minus root is not belongs to in the interval. Okay, na? So one point is exist between 1 and 4. Therefore, verify the Lagrange's mean value theorem. Okay, is that clear? See the next example. So discuss the applicability of Lagrange's mean value theorem for f of x is equal to mod x in closed interval minus 1 comma 4. So given modulus function which is defined here, minus x. So when x less than 0, mod x is equal to minus x. When x greater than 0, mod x is equal to x. So that is equal to here. So it is a clearly continuous from minus 1 to 1. There is no breaking. It is clearly continuous. Now differentiable at the point 0. Because minus 1 to 0 is a differentiable. From 0 to 1 is the differentiable. But we are breaking 0. Now discussing at the x is equal to 0 is differentiable or not. That is equal now finding left hand derivable and right hand derivable. So that is equal left hand derivable L f dash of 0, that is equal to limit x tends to 0 minus f of x minus f of 0 by x minus 0. And f of x is equal means x less than 0. X less than 0 f of x minus x. That is a minus x minus 0 by x. That is equal to minus x by x cancel minus 1. That is the left hand derivable minus 1. Similarly right hand derivable or f dash of 0. Limit x tends to 0 plus f of x minus f of 0 by x minus 0. And x tends to 0 plus means x greater than 0. X greater than 0 f of x is x. That is x. X minus 0 by x. X by x is a 1. So right derivable is 1. So both are not equal. Left derivable is not equal to right derivable. So that is given function is not derivable at x is equal to 0. x0 belongs to minus 1 comma 1. So therefore Lagrange's mean value theorem is not applicable in closed interval minus 1 comma 1. Okay. So next one. So find approximately square root of 17 by using Lagrange's mean value theorem. So this is one of the application we have to finding the approximation value by using Lagrange's theorem. So that is using the another form of Lagrange's theorem. So that is equal assumption is, so but there is no given function. Assumption the function is root 17 again, and the function is root x, and f of x is equal to root x. This is assumption the function root x. Now choosing the interval. How to choose the interval here? So near root 17, the perfect square root, which number near to 17? That is a 16. So that is equal to 16 assumption near to 17, the perfect square root. The second value is we have to finding the value 17. So root 17. So that is equal to interval assumption. Closed interval a comma b, 16 comma 17. So is a clearly continuous and differentiable. Now finding the differentiation. So assumption the given interval is a comma a plus h, and assumption the second interval, that is second form of the Lagrange's theorem. This is a is equal to 16, a plus h is equal to 17, and a is equal to 1. So and f dash of x is equal to here root x derivative 1 by 2 root x. So it exists for all x belongs to 16 to 17. So by Lagrange's mean value theorem, we have there exists a real number theta belongs to open interval 0 comma 1 such that f dash of a plus theta h is equal to f of a plus h minus f of a by h. This is a statement of Lagrange's theorem. Now substituting all values, so f dash of a plus theta h. So theta h is a negligible end because theta is belongs to 0 comma 1 gada. So that is the assumption only, because you have to finding only approximate value. So that is the reason is now assumption theta h is negligible. That is equal to here f dash of 16 is equal to f of a plus h and f of 17 minus f of 16 by 1, h is equal to 1. So f dash of 16 means 1 by 2 root 16 is equal to f of 17 means root 17, f of 16 means root 16. So that is equal to 1 by 8, 2 into 4 here, 1 by 8 is equal to root 17 minus 4. Therefore root 17 is equal to 1 by 8 plus 4. So simplification is 1 8 plus 4, 4.125. This is root 17 is, the value is 4.125. This is the approximation value of the root 17. This is using the mean value theorem. Okay. See the next example. Yeah, this is the important question, the long question. If 0 less than a less than b, prove that b minus a by 1 plus b square less than tan inverse b minus tan inverse a is less than b minus a by 1 plus a square using Lagrange's mean value theorem. Next, deduce that from this inequality we have to showing this second inequality. And okay na, this is a very very important question, the long question. So let f of x is equal to tan inverse x, because but not given in the question, but in the inequality in the middle term is in terms of tan inverse. Okay, that is equal assumption the function is tan inverse x, but given interval is always given 0 less than b kada, and a to b, the interval is a comma b. So tan inverse x is always continuous and differentiable, and derivative is f dash of x is equal to 1 by 1 plus x square, which is exist for all x belongs to open interval a comma b. So by Lagrange's mean value theorem, there exists one point c belongs to open interval a comma b such that f dash of c is equal to f of b minus f of a by b minus a. Okay na, f dash of c is equal to here 1 by 1 plus x square kada, x plus to c replacing 1 by 1 plus c square. F of b is equal to tan inverse b minus f of a is equal to tan inverse of a by b minus a. Let the equation 1. So since c is between a and b, and which is can be right a less than c less than b. So now here assumption c is the point, this c is converted in this form. the c is converted, the form is 1 by 1 plus c square. When the c is converted this form, automatically a and b is also changed. So see that. First of all, what is the form here? 1 by 1 plus c square. First c square. Now squaring on both sides. A square less than c square less than b square. Next one, adding 1. Adding 1 plus a square less than 1 plus c square less than 1 plus b square. Next one, reciprocal. So now reciprocal of, so 1 by 1 plus b square less than 1 by 1 plus c square less than 1 by 1 plus a square. So interchange the signs and so automatically changed, that is equal to here from equation 1. 1 by 1 plus c square can be write from equation 1, tan inverse b minus tan inverse of a by b minus a. Okay na? So now multiplying b minus a on both sides. Multiplying b minus a, that is equal to b minus a by 1 plus b square less than tan inverse b minus tan inverse of a less than b minus a by 1 plus a square. So this is the inequality proving. Next, deduce that in the above inequality substituting a is equal to 1, b is equal to 4 by 3. So this is the only assumption from the given inequality, directly substituting a is equal to 1, b is equal to 4 by 3. That is equal to 4 by 3 minus 1 by 1 plus 4 by 3 whole square less than tan inverse 4 by 3 minus tan inverse 1 is less than 4 by 3 minus 1 by 1 plus 1 square. That is equal to simplification 1 by 3 by 25 by 9 less than 4 by 3 minus 5 by 4 less than 1 by 3 by 2. So that is equal to, hence, so adding 5 by 4 on both sides. So tan inverse 1 is equal to 5 by 4. So now adding 5 by 4 on both sides, 5 by 4 plus 3 by 25 less than tan inverse 4 by 3 less than 5 by 4 plus 1 by 6. So this is the inequality proving. So next question. Show that 5 by 3 minus 1 by 8 less than cos inverse 3 by 5 less than 5 by 3 minus root 3 by 15. So that is equal, directly we have to showing here. So here middle term is cos inverse here. Cos inverse. So let the function is f of x is equal to cos inverse x. But there is no given interval, the particular integral. Now assumption the interval is a comma b. So that is equal to f of x is equal to cos inverse x. X belongs to, let assumption the interval a comma b. Both are positive number. So clearly which is continuous and differentiable, and differentiation of f of x. So f dash of x is equal to derivative of cos inverse x, that is minus 1 by square root of 1 minus x square, is exist for all in a comma b. So by Lagrange's theorem, this is Lagrange's theorem, f dash of c is equal to f of b minus f of a by b minus a. So that is equal to a, f dash of c is equal, can be right, f dash of x is equal to minus 1 by square root of 1 minus x square. X plus low c replacing. So that is minus 1 by root of 1 minus c square is equal to f of b cos inverse b minus f of a cos inverse of a by b minus a. So now since c is belongs to open interval a comma b, that is a less than c less than b. So now c is changed, which is converted to this form. Okay na, c is converted to minus 1 by root of 1 minus c square. Okay na, first of all squaring. Now squaring on both sides, a square less than c square less than b square. Next minus, multiplying with minus 1 and adding 1. After multiplying minus 1 means change the signs. Okay na, sign change అవుతుందండి. 1 minus a square is greater than 1 minus c square is greater than 1 minus b square. Next one, square root on both sides. Square root of 1 minus a square is greater than square root of 1 minus c square is greater than square root of 1 minus b square. Okay, now reciprocal. So reciprocal means 1 by square root of 1 minus a square less than 1 by square root of 1 minus c square less than 1 by square root of 1 minus b square. So assumption is, so now minus multiply with on both sides. So after multiplication minus 1 by square root of 1 minus a square is greater than minus 1 by square root of 1 minus c square greater than minus 1 by square root of 1 minus b square. So after multiplication minus means interchanging the signs. So from equation 1 replacing minus 1 by square root of 1 minus a square is greater than cos inverse b minus cos inverse a by b minus a greater than minus 1 by square root of 1 minus b square. So now here multiply with b minus a on both sides. That is equal to, take the minus common. So take the minus common is interchanging the signs. So we have to write a minus b by square root of 1 minus b square less than cos inverse b minus cos inverse of a less than a minus b by square root of 1 minus a square. So interchanging it. Okay na? So here b minus a means minus common, that is a minus b. Minus is a cancel. Okay. So this is a inequality end. In the inequality now we have to substituting a value, b value. So put a is equal to 1 by 2, b is equal to 3 by 5. That is equal to 1 by 2 minus 3 by 5 square root of 1 minus 9 by 25 less than cos inverse 3 by 5 minus cos inverse 1 by 2 less than 1 by 2 minus 3 by 5 square root of 1 minus 1 by 4. So simplification is minus 1 by 8 less than cos inverse 3 by 5 minus cos inverse 1 by 2. 1 by 2 means in the cos 5 by 3 kada. So that is equal to 5 by 3 less than minus 1 by 5 root 3. Now adding 5 by 3 on both sides. So adding means 5 by 3 minus 1 by 8 less than cos inverse 3 by 5 less than 5 by 3 minus root 3 by 15. And here rationalization root 3 by root 3. So here root 3 by root 3 is the rationalization. Dividing multiply with the root 3. That is equal to root 3 by 3 into 5, 15. So this is a required result of the given problem. Okay. Here, thank you. This is the Lagrange's mean value theorem and its problems. For more videos, please do subscribe my channel, like and share it. Thank you.